student of class 11. Today I am going to discuss centripetal acceleration and its expression. So let us first of all know what do we mean by centripetal acceleration. So this is centripetal acceleration. Is acceleration means rate of change of velocity. But what do we mean by centripetal? Centripetal is made by two words, centri plus petal. And centri means center. A petal means to seek. Means centripetal acceleration means an acceleration which always seeks the center. Centripetal means centripetal acceleration means the acceleration which always seeks the center of any circular path. That is, the acceleration which is always directed towards the center of the circular path. Center of the circular path means motion of the object should be circular. If the body is moving on the circular path with uniform velocity, with uniform speed, then the acceleration will be there, and that acceleration is always directed toward the center of the circular path. So this is called as centripetal acceleration. Let us consider an object of mass m is moving on this circular path. This is the center of the circular path of radius small r. An object is moving on it. Sometimes the object is at this p and it is moving along anti-clockwise direction. So at this point the direction of the speed means velocity will be v1 and it is directed along the tangent on the circular path. Let the body reaches to Q. In time delta t, time is very small. In a small interval of time, let the body of mass m reaches to Q. At Q, the velocity will be again tangentially to the circular path. As velocity is vector quantity, a speed is a scalar quantity. The body is moving with uniform speed, means the speed at p is equal to speed at q, but velocity at p is tangentially outward and velocity at q it is also tangentially outward. So due to change in the direction of velocity at p and q, there will be acceleration. And it will be directed along the center of the circular path. This is r. The angle made at this center, let it is delta theta, as we have considered here. Time is very small, so the angle will be very small. First time the body is considered at p and it reaches to q in time delta t, and the velocity is tangentially v1 at p and v2 at q. It is along the tangential direction. So we will prove here that the direction of the change in velocity is always directed towards the center of the circular path. And when we calculate the acceleration, then the direction of acceleration will be along again towards the center of the circular path. For this, we have to take another point, and from there V1 and V2 is considered in their direction. Means we are taking a point here A, and from A we will draw V1 with same magnitude and in the same direction. So this will be here V1. This will be V1. Now from A, common point Q is V2 is drawn in the same direction. So V2 will be in this direction here. So we will take here V2 here again. And then we will complete the triangle here, and this will be this, let the tip of V1 is B and tip of V2 is C. So BC, this will give the change in velocity, and change in velocity as we have drawn here the triangle for the same vector, so the angle between these two vectors will be delta theta. It will be delta theta. So if time is very small, and due to this is the arc, PQ is the arc, and if we draw from here, if a straight line is drawn, so what will happen if delta t tends to 0? If delta t tends to 0, if delta t is very small, then what we will consider that at that time this arc PQ will be equal to this chord PQ, this straight line, and therefore this angle, as we have considered this vector parallel to V1, here AB is parallel to this V1 and this V1, and here AC is parallel to this V2. Therefore, for the small time, if this angle is delta theta, so this will be also delta theta. So these two, now we can say that these two triangle OPQ and triangle ABC, that will be the similar and that will be the congruent, same, and therefore its angle will be same. So now considering triangle law of vector addition, we can write here this AB, then this is plus BC, and then CA minus, we can write CA, this will be equal to 0. Here minus is taken due to the direction of the vector V2. So we can write here AB plus BC is equal to AC or CA. We can write here this one. So we can write here AB is equal to V1, AB is equal to V1, and BC is equal to delta V, and this AC is equal to V2. Therefore from here we can calculate delta V is equal to V2 minus V1. Delta V is equal to V2 minus V1. So this is the change in velocity. That is why we have written previously that this BC will represent change in velocity. It comes from triangle law. We have used here triangle law. We have using triangle law of vector addition. So delta V is equal to V2 minus V1. But in magnitude wise, V2 is equal to magnitude of V2 is equal to magnitude of V1 is equal to, we can write V here. This magnitude is same. Only due to change in the direction, there is change in velocity, and there is change in velocity, and due to which there is acceleration. Now, from triangle OPQ, we can take this angle is equal to arc by radius. Arc means this, as the arc is very small, so it is a straight line. So we can write here PQ divided by OP. Similarly, from triangle, if we are considering from triangle ABC, we can write delta theta is equal to BC by AB. So this is equation number 1 and this is equation number 2. From equation 1 and 2, this is also delta theta, this is also delta theta. Therefore, from equation 1, we can write PQ by OP is equal to BC by AB. PQ by OP is equal to BC by AB. So, what is this PQ? Let this PQ is delta S. We can write here PQ is equal to delta S, and OP is radius of the path. So, delta S divided by R is equal to this BC is change in velocity delta V divided by this one, as we have told magnitude of V1 is equal to V2. So we are taking here value, so this will be V. So we have got here an equation that delta S by R is equal to delta V by V. Now dividing by delta T on both sides. Delta T on both sides. What we will get here? Now eliminating this part here. What we will get here? Delta S by delta T into 1 by R is equal to delta V by delta T into 1 by V. Now taking limit, if we take limit delta T tends to 0, what we will get? Delta S by delta T, this will be equal to ds by dt, and ds by dt it will become V. So it will become V. Now taking limit on that side, limit delta T tends to 0, we will get delta V by delta T is equal to dV by dt, and dV by dt we all know that it is acceleration. So acceleration is denoted by A. So these two will be substituted in this equation. We will get here 1 by R into V is equal to A by V. Means, or we can write V by R is equal to A by V. So we can write now here V square, or A is equal to V square by R is equal to A, or we can write A is equal to V square by R. This is the expression for acceleration in this case. Now come to the direction. What will happen? This was the velocity V1. Now let the Q tends to P. Point Q tends to P. What will happen? क्या होता है यहाँ पर देखिए, अगर Q को P पे ले आता हूँ, then V1 V2 will merge with V1. This V2 will come along V1. At that time in the triangle, this triangle here I have eliminated, in the triangle this is V1, this is V2, this is delta theta, and this is delta V. So at that time, what will happen? The change in velocity will become delta V will become perpendicular to radius of perpendicular. Delta V will become perpendicular on, we can write here, on V1 or V2. What will happen? If Q comes to P, at that time V2 will merge with V1. At that time, from this we can say that change in velocity will be perpendicular on V1 or V2, because this is in this direction. So we can say acceleration, in this case acceleration is always directed toward the center of the circular path. So hence this is the expression for centripetal acceleration. Centripetal acceleration. So this is all about the centripetal acceleration and its expression. So this acceleration is always directed toward the circular path, center of the circular path. Means it is always seeking the center of the circular path. Thank you very much.